Now in JFET, we need to bias JFET. We need to find out reason behind it. What is actual reason because of which we are using different biasing methods in the JFET. JFET is a device made up of semiconductors and hence it depends upon temperature. Value of drain current depends upon temperature. Let's see how. So need of JFET biasing is against temperature. Now we can see that as temperature increases in JFET, crystal ions will start vibrating because JFET is made up of substrate and drain and source. Now what happened is, as temperature is increasing, as temperature increases, crystal ions will start vibrating in JFET. Crystal ions starts vibrating. As crystal ions are vibrating, they will restrict flow of electron. This will restrict flow of electrons from source to drain. Now again we will see, as temperature is increasing, crystal ions in JFET starts vibrating. This will oppose or restrict motion of the electrons from source to drain. As electrons are not able to pass or electrons are not able to go from source to drain, drain current will start decreasing. Ultimately, because of this, as temperature is increasing, drain current ID decreases, which can be shown with the help of following graph. Now drain current ID is decreasing as temperature is increasing. Let's try to find out, or let's try to draw drain current graph for three different values of temperature T1, T2 and T3, where T3 is having more temperature or T3 is having more value than T2 than T1. Hence, as temperature is increasing, we will see that, see, this is graph for temperature T1. As temperature is changing from T1 to T2, the drain current will decrease. This is for T2. Similarly, if further will increase the temperature, then drain current will further decreases and will be becoming like this. As temperature is increasing from T1 to T2, from T2 to T3, we can see that there is decrement into drain current ID. So we can easily say that drain current ID decreases with increasing temperature. But if we observe carefully, there is one point on the characteristics for which drain current is independent of the temperature. Again, I'll repeat that. There is one point on the characteristics or transfer characteristics. We can see that for that particular point, drain current is independent of the temperature, and we must bias JFET at this point, say point X, giving value of VGSQ and IDQ. This is the first point why we required to bias JFET, because as temperature is increasing, drain current is decreasing. But similarly, we can write that drain current is decreases by 0.7% per degree Celsius. the decrement in the drain current can be calculated as 0.7% per degree Celsius. That means this implies as temperature increases by 1 degree Celsius, value of drain current decreases by 0.7%. Now, in first case, we have seen that as temperature increases, drain current decreases. But there is also a point in which we'll come to know that as temperature is increasing, drain current is decreasing. Your question will be how this is happening? Simple. Now, the second parameter on which the drain current depends is channel length. So let L is length of channel. Now this length of channel decreases with increment in the temperature. So we will write that if temperature increases, then channel length L start decreasing. As channel length is decreasing, drain current will increase because now electrons are having very less barrier. They can easily come forward and cross the barrier, that is depletion region, to reach to the other side, that is from source to drain. So as temperature is increasing, channel length is decreasing, and ultimately drain current ID increases. And this amount can be written as, we can say that VGS is changing by 2.2 millivolts per degree Celsius. Now we are confused. The reason is that drain current is increasing with the temperature for certain point, whereas it is decreasing with the temperature for another point. Then how to bias JFET? So JFET is biased at a point where drain current is independent of the temperature, and at the same time increment in the drain current is equal to decrement in the drain current. Hence we can write JFET is biased at increase in drain current is equal to decrease in drain current. At this point we are going to bias JFET, and this condition is called as zero temperature drift.